That's always a very uplifting tune. All right, our next presenter is Mike Glukhovsky. He's going to be talking about RethinkDB, which is an open source database for the real-time web. Here he is.
Hey guys, I'm really excited to talk to you about a really cool project that I've been spending a few weeks working on. I'm one of the founders of Rethink. My name is Mike Glukhovsky, and what I want to talk to you about is 3 different technologies today. So I'm going to try to rush through this. I have a very rapid way of speaking, so I hope you guys keep up with me. But I want to talk about RethinkDB, which is an open source distributed database that's really designed for building real-time apps. It's a very general purpose, very good database, but it has a lot of features that make it really easy to build complex, rich real-time applications. We're going to talk a bit about what that looks like in a minute. I want to talk about using React, which is some front-end technology that I use to build this project, and then the Raspberry Pi. And this is a little device that I built right here that I'll talk to you guys about. It's a Raspberry Pi with a couple parts and a custom case that we built for it. And I want to tell you a bit about the project that we wanted to start at our company, just as a little hack project that we wanted to play with. So before we dive in, it's important to say what real-time apps are. I think most people probably remember their first experience with Google Docs. When you started up Google Docs, you probably saw like a blank document with a blinking cursor, and you're like, this is just a text editor. But then you start to see people type, and other people start to type. You can see their text appearing in real time, their comments, and you get this experience like, whoa, this is not just your average text editor. There's something very special going on here. And so this is what we mean by real-time apps. There are real-time updates being pushed from client to client, from server to client, and as these updates come in, they affect what you perceive to be the state of reality. And so another popular example is Slack. Raise your hands if you use Slack here before. Raise your hands. Yeah. So I usually, when I ask this question, the whole room raises their hands because Slack is amazing. And the reasons why Slack is so great, why it had so much traction over, it's just chat. Like people have tried doing chat many times before. But the reason why Slack really nailed it is because it has this feeling that it's always present, it's always with you. It doesn't matter whether you're on your phone or your desktop or your tablet, it travels with you, and real-time updates keep coming in at you. You have channels and messages you can send with each other, but it kind of feels like you're collaborating in real time. And that feeling, that user experience is so potent that a lot of people really want these kinds of apps. And so, that brings me to talking about building a real-time app like this with Raspberry Pis, RethinkDB, and React. This is our little friend, by the way, the Thinker. He's right here. He's our mascot for the project. You'll see him pop up throughout the presentation. So basically, this is the RethinkDB office. We're based in Mountain View, California. We have about 20 folks, and we've been building the company for about 7 years. It's an open source project that has well over 100,000 users, but we have a small team that works out of Mountain View to work on the core project. And so, at RethinkDB, we like to have a lot of fun. This is us designing the database, some new features. We meet a lot of folks who come in the office and hang out with us from other cool companies and other cool projects. So we wanted to have a really nice way for them to just check in and say, hey, I'm at the office. I want to talk about who I am and why I'm here, but just allow them to just check in. And so we wanted to build a little photo booth. And so this is the photo booth that we built. And it was an opportunity to play around with some new features we had. We had shipped these real-time features, change feeds, in RethinkDB a while back. And so we wanted to sort of put them to the test and start to build a real app with it. And something hardware-based, because we usually work on software. We're a bunch of database engineers and low-level programmers, and we don't get an opportunity to play with physical devices very often. And so, we started with the Raspberry Pi. Raise your hand if you've worked with the Raspberry Pi in the past. Yeah, so you guys are going to be very familiar with this. I'm going to blow through this pretty quickly. But the Raspberry Pi is really neat because it's so cheap and it's so capable. And when you start to play with it, you realize that you can use it in a lot of different ways. So this same box has been repurposed for a number of different projects. Right now, it's a photo booth, and we've been working on this for a little while. But we also alternately use this as a security system, like a monitor to detect like when people walk by, to alert us. It's been used for temperature sensing and to help us keep track of temperatures in our server room. And so we keep finding new ways to work with this. And we built this little chassis to house it. And we have a couple parts in here that I'll just describe to you. So the Raspberry Pi itself is pretty straightforward. They've gone through a couple revisions now at this point. And this is a B+. This is the touch panel that's on the front. It's a surprisingly nice, really rich colors, and allows you to do a lot of touch motion, which is nice when you have limited input. So Adafruit sells a version of this that is a little pricey but nice, and I think there's a bunch of generic ones also available, like on sites like Alibaba and things like that. If your budget is something that's concerning to you. I think I've seen these panels go for as cheap as $25 actually. And so, so the Raspberry Pi functions as the hardware for the client. When someone checks in on our photo booth, and I'll show you what that looks like in just a moment, then they're going to post an update to Twitter. It's going to show them that they appeared in the office and have a little badge, a little sticker on it. So let's do that now, actually. If you guys go to Twitter, I'm going to show you what this looks like in action. So if you go to Twitter, we have this Twitter feed, which is twitter.com/thinkerbooth. And so this is the photo booth tweet. I just took one just a minute ago of what the audience looks like. Just refresh. Here we go. So this is the view from the stage. And so on this device, if we you can see it has a little display of what's going on from the camera that's on top. And I'm just going to point it at you guys. Actually, I'll take a little selfie. There we go. That's terrible. Let's try that one more time. Okay, so now it got stamped. I'm going to tweet it. I'm going to do the same thing on the desktop so you guys can see what it looks like on the big screen. And you should see a little tweet roll in here in a second. So here you can see the same thing. This is what the interface looks like on the Raspberry Pi. We have the main just webcam image here, some camera controls here, and then recently tweeted photos that we had down here. So I'm going to take a little selfie here as well. Okay, and then we're going to tweet it. And we should see a real-time update pop in the bottom. And if we go to Twitter, that's my selfie from before. Not a great selfie. And then there we go. So basically, a real-time update was pushed from the device and from my laptop, and it was pushed up to a central backend that basically pushed out a real-time update to Twitter and updated all the clients. You can see I also have this view to be able to manage all of the photos I have, and so you can see that on this side, if I take another photo and then I tweet it, you can see that it gets pushed and then real-time updates propagate on both sides. So what's nice about this is that we have one photo booth, but we could have 50 photo booths or 100 photo booths or 1,000 photo booths, and they don't have to know anything about each other. They're completely stateless, and they're all clients that basically just push data into this backend, and then it eventually gets pushed updates across the entire set of other clients that we have, including Twitter. And so, the other key piece to this is the front-end interaction. And so for that, I decided to use React. I first built this when React was first coming out, so I was getting to grips with how it worked. And who here has worked with React before? Raise your hands. Okay, so a fair number of you. So you're going to be familiar with some of the concepts here as well, and I'm going to talk about how they apply to greater application architecture. So React is a lot of people confuse it with an MVC library or something that sort of tries to handle a lot of different components. React is just a view layer with a lot of modern features. So it espouses a view of building software as components. You have components that reuse, that you apply attributes to, that you can combine in different ways and build complex applications, rather than the days of jQuery when we're sort of twiddling things and moving them around the page. It has a virtual DOM, so you're able to make updates without having to do a lot of DOM updates yourself. Very efficient, very fast, and it has unidirectional data flow, which we'll talk about in a second. So basically, components are defined in JavaScript and JSX, which is a language that is very similar to JavaScript. It's kind of a mixture between HTML and some JavaScript mixed in as well, and it allows you to create complex views. And these components are really just state machines. So what you're doing is you're modifying the underlying state. There are components that have state and don't have state. But what you're doing is, as you advance the state, the component changes itself to reflect the updated reality. So in our example, this photo booth app, there's a couple components. We have the main photo booth component. It manages a socket.io connection for real-time updates, and it's a stateful component, so it's keeping track of that connection. We have the camera, which is a component that just basically manages the webcam stream. Has two primary states, live and preview mode. And those are the two states that we're switching between, and it has actions for switching states and then actually doing some tweeting. So it's also a stateful component. The film strip, which is at the bottom, shows all the recent photos that come in from the photo booth. And because that is not making any decisions, is not taking any actions, it's just subscribing to the stream of updates, it's a stateless component. And each photo is also a stateless component because they're just sitting there and they will update themselves and be added or removed as necessary. So React encourages stateless components over stateful components. If you ever can avoid putting state into your components, it's a good idea. State is your enemy. Because every time that you have state, you have to figure out who needs to be updated of what where. And this becomes very complex to be able to orchestrate, which is why a lot of previous JavaScript libraries that try to do complex software architecture became cumbersome and hard to use as you scale the size of your app. And one of the reasons this is possible in an efficient manner is because React has a virtual DOM, it has lightning fast updates. Each state change triggers an update, and you have efficient diffs that patch changes onto the virtual DOM. And this is the most important part about React to me, is the fact that it espouses unidirectional data flow. So unidirectional data flow is one-way reactive data flow. You start from the bottom, and data starts from the bottom, state starts at the bottom, and then it ripples to the top. And so what happens is, because you have state starting from one location, it makes it easy to think about state. You have one source of truth, and as you update that source of truth, all of the stateful and stateless components above it will react and will update themselves to adjust in the new reality. And so this meshes really well with RethinkDB, because we think a lot about these things at RethinkDB as well. Except we believe the unidirectional data flow shouldn't start just in your browser, but should start all the way from the database and flow to the top. So let's talk about what that looks like. So in designing this photo booth, there's a couple things to sort of think about. You have your Raspberry Pi photo booth, which has a React front end and a Node.js back end. In this case, it's running Koa and Socket.io. And it's talking to a RethinkDB cluster. So RethinkDB is a distributed database. You can have lots of nodes that are running in the database. And it doesn't matter which one you're talking to. It'll scale linearly. And it has mechanisms that allow you to subscribe to updates. So each photo booth is talking to the cluster. And then we want to tweet the photos in real time. So you can follow Thinker Booth if you want to see some of the photos that will be coming in shortly. But we want to have a different service, like a different microservice. So we have this Twitter service, which is going to sit separately. And what it's going to do is it's going to watch for each new photo that comes in. And every time there's a photo that comes in, it has one job, and that's to tweet that photo. So what happens is that we have basically two really stateless services that don't know about each other and need to somehow communicate. And so the question is, we have these two services, the photo booth and then the Twitter service. And how should they communicate? How should they talk to each other? How should they inform each other of real-time updates? And so this sort of brings us to the fundamental problem with building something like Slack, why it's so hard to build real-time apps. And it's because it's hard to keep track of state in real-time architectures. So if we take this example, where you have a lot of clients that are communicating and talking to each other, how do you figure out who gets what change? How do you inform everybody of the updates that have happened? If you have one app running in your browser, it's easy. But if you have lots of apps running in lots of different environments, how are they supposed to inform each other of what the state of truth is, of what reality is? And so, this is what it ends up looking like. I hate architecture diagrams, but it bears looking at this one for just a minute. You have a bunch of different real-time web apps and services. Usually, people solve this problem by saying, use a queue. And a queue, something like RabbitMQ or Kafka, is fine, except that now they'll communicate state, but as you can see, it gets pretty complicated, because now you split your source of truth between two places, your database and your queue. When you have state in multiple places, it's hard to reason about. It's hard to figure out what is actually happening in your architecture. You want the same level of control that you get in something like React. And so, polling data is the other way that people typically solve this problem. When you want to keep track of updates, you got to just poll the database or poll your data sources. And this is cumbersome for all the reasons that we know. Polling happens on a time interval, and it's hard to make sure that you have the same instant lightning update. You have to synchronize polling. It's not very elegant. And it doesn't work very well for a world, which is a lot about streams and unidirectional data flow in the front-end world. And so because these problems get really hard, adding a new real-time feature to your entire application, to your architecture, gets really hard. Every time you make that question, if you have that question that you have to face, should we consider building this new feature, you have to think about all the work you have to do to figure out how to keep track of state. And so the other thing is, if you're building something like Slack, you have to figure out, how do I route these messages? I have different channels. Do I broadcast them to everybody? Do I figure out which users are allowed to get a certain set of messages, or which ones should for efficiency's sake? So it gets really messy, it gets really complicated. So that brings us to RethinkDB. And so RethinkDB is, as I mentioned, it's an open source database for building real-time apps. It's a NoSQL database, So it has a lot of SQL-like features like distributed joins and a lot of other group by, a lot of MapReduce, things that might be familiar coming from their database systems. But it's a NoSQL database. You store documents in it, JSON documents. And it's schemaless, so you can just throw in new JSON documents. We picked JSON because it's the data format for the web, for better or for worse. And we have a query language which makes it very easy to work with JSON documents. And it's a distributed database, so it's really easy to scale it. All you do is just throw nodes at it, and go to a web UI, enter a number, hit a button, progress bars go, and you instantly have a sharded replicated cluster. People have run 30 node clusters on Amazon at 1 million ops per second in like mixed read-write workloads. One of the largest online brokerages in the world runs 25 million users every day through this on a 25 node cluster in 3 data centers. And I just found out about this use case a few weeks ago. Maybe about a month or two ago. And it turns out that NASA is using RethinkDB to deliver updates on the spacesuits that they use in the spacewalks. So they have a desire to find out what's happening in real time to do analysis on when an astronaut goes out in an EVA. They have to figure out if the spacesuit's going to malfunction. Turns out there's a risk of drowning in space, which is horrifying to think about. But the spacesuit can fill with liquid, which has happened, I think, on 1 or 2 occasions. There's been some malfunctions. And so they have to figure out, how do we build a large real-time streaming architecture to try to support these really mission-critical use cases? And so NASA is using a Docker, Node, and Rethink architecture to be able to manage manage these streams that can update themselves in real time. And they can scale it very easily. And you can have tens of thousands of streams coming from the database on a single node and then scale it linearly from there. So I mentioned that RethinkDB lets you do streams and it's built for real-time apps. But what does that actually mean? So here's the fundamental piece. So RethinkDB lets you subscribe to change notifications on queries, on database queries. What this means is that traditionally a database, if you wanted to write a query and get a response, you would do exactly that. You would write a query and then wait for the database to finish and return a response to you. And if you wanted to stay updated on the value of that data, you'd have to run the query over and over. This is polling. What RethinkDB lets you do is it lets you write a query and then add this term at the end, .changes. This is an example of reql query. Reql is our query language, like SQL, but for RethinkDB. And in this case, we're taking the table photos and we're saying .changes. And what this does is it opens a stream. Now whenever something gets added, a document's added, modified, or removed to that table, you'll see a little change notification, a little ping, that will tell you that something's changed within your database. So this means no more polling. The database will push changes to your app. It'll just open a stream, and it'll just continue to send updates as they come, once every few minutes, once every few milliseconds, once every few hours. But you'll instantly get notified, and you'll be able to react to what's happening in the system. And this is the fundamental utility that we have for RethinkDB that allows you to build these scalable real-time apps, these change feeds. Each server, this is an example of the same architecture diagram. Each server just subscribes to a change feed. It doesn't have to talk to anything else. It just talks to RethinkDB. It inserts data into RethinkDB when it has new data that the system should know about. And then all these change feeds will alert every single subscribed app whenever a change comes in that affects it. So what the magical part is that these servers are now stateless. You can see they're not coupled together. It doesn't matter how many of them you add. You can just scale them linearly. This is the beauty of building things without state at a higher level. You're able to scale things really easily because you don't have to think about who's supposed to talk to who and how to manage the data. So this makes it really easy to build a whole class of applications, things like collaborative web and mobile apps, multiplayer games. You have lots of player events that are affecting each other in a real-time world, streaming analytics, so you can figure out what's happening in real time while you're running your transactions. You can figure out like threshold analysis. Are we getting more than 70% or 60% on a certain number? Real-time marketplaces, ad exchanges, connected devices, and that's what this is. This is my favorite type of problem with real-time apps is IoT, because that's the kind of stuff that NASA deals with, where they have devices that are just emitting data streams in real time. In 2 years, I think 97% of traffic on the web is going to be IoT. It's not smart traffic. It's just devices that are just pouring out streams of data. And there's a question of how do you figure out what all that data means, and how do you react, because that data has transient value. It expires in the moment. If you can act on it, you can generate enormous value from it. And so we have people who are building like farms in the Midwest, and they just have very smart farms with sensors everywhere. And they have this farmer sitting in the field with an iPad and drawing out like geometry for his field, and then they want to do variable fertilization and want to figure out the ideal time. And they send drones out to collect all the data. And so all this data is pouring in, and they want to figure out how do I make sense of it and how do I, act on it in the moment. And so that's the kind of stuff that RethinkDB helps people build. So let's step back for just a minute to the query language. I want to show you exactly how this works and then show you what's going on in this app that I actually built. You can see some of the real-time updates. So this is an example of a REQL query. This is just getting the unique last names. So it's a chainable query language you may be familiar with if you're familiar with things like jQuery or anything else. Data flows from left to right. So you start by accessing the database table, r.table users. Then we isolate one document property. We pluck it with the last name. We get the consolidate any duplicate values with distinct, and then count. You'll notice that unlike something like SQL, where you're sending over a string that represents the change you want to make, it just looks like native code, because it is native code. We do a lot of magic behind the scenes to take this whole thing, consolidate it to a distributed expression, and push it out to the cluster to be efficient. But it looks and feels like native JavaScript, so you can just write it as code. And unlike Mongo, where in Mongo you would write a JSON document that represents the transformation you want to make to your database, this is a lot easier to understand, and it integrates into your programming language a little bit more easily. So because of this, you're able to write very rich queries on the client, but because they get run on the server in an efficient distributed fashion, you can write really complex, crazy things that subscribe to streams and do all sorts of interesting things with it. So name a language, there's a driver for it: Python, Ruby, JavaScript, Erlang, Lisp, Haskell, Go. If you name a language, there's a huge community behind it, because at this point, the community for RethinkDB is well over 150,000 developers, I think nearing 200,000, and has a huge ecosystem on GitHub right now. So you can do a lot of really complex things with REQL. Transformations, aggregations, control flow, branching, looping. It's really a programming language that masquerades as a query language. And so the magical thing is that change feeds work on queries as well. So if you want to get notified when a user profile gets over 30 likes, then in this case, we're filtering for each document, r.row, where the property likes is greater than 30. And the nice thing is that you could write this query, get a response, but you can just open a stream with .changes. And now you're going to get subscribed to the stream of real-time updates. And every time that a document comes in that gets affected by this query, every client subscribed to it will get notified. So let's take some photos. I want to show you exactly how this works. And to get this going, I want you guys to try to pitch in a little bit. So if you go to this URL, https:// the S is important, because I just discovered that recent versions of Chrome turn off the webcam if it's not on HTTPS. They don't allow you to use the webcam on sites that don't use HTTPS. So make sure you include the S, and go to //photobooth.ngrok.io. And I'm going to jump out of this for a second so I can just show you what's going on here. So we might be stymied by our internet connectivity, which is always a challenge. But if you guys start to send real-time updates, if you guys start to push in new photos, just open the webcam, you get a little sticker with the thinker at the bottom, you get a chance to take a new one. And you should start to see some photos coming in. And so what's happening is that I have two apps here. I have the photo booth, which is showing our recent photos. If it's taking a while to load the image, it's because I'm using a really mediocre static file server. But basically, these photos are starting to come in, and we can go to the RethinkDB dashboard. Now I'm going to load this up again. So every instance of RethinkDB comes with a web UI. And the web UI gives you a way to see what's happening in the cluster, to write queries. And so in this case, this is our cluster right now. You can see some writes are happening. This is you guys submitting some photos, so good work. Let's see if we got any more coming in. So if we go over here, I just want to show you how this works. You can look at the tables. You can see that we have about 40 images right now. And if you can see, do the sharding replication, you can just enter a number and click a button. In this case, I don't have enough machines in my cluster to be able to accommodate these requirements. But you can see it's pretty trivial to do sharding, replication, and clustering. If we go to the Data Explorer, so this is where you can write queries to actually query the database and see what's going on. So if we just want to see what's in it, we can just say photos. And you can see we have a bunch of documents. Each document gives us a location with a file to serve, the ID, a MIME type, and the date time. We can run some queries. For example, we can say .order by index. So we can say order by an index I've pre-created called date. I think it's called date. Oh, it's time. That's why. So I can say this, and I can say .limit like 10. This will give me like just the 10 elements. You can see it just feels like programming. And so we can now say, okay, so this and then .changes. I'm actually not sure if we're in ascending or descending order right now. So I'm going to pull this off, and we're just going to go in the table in general. So if right now what I've done is I've opened a change feed on the table, And you can see that as photos start to come in, there we have some people tweeting. There we go. Yeah. Nicely done. OK, so you can see that we have change events. So let's take a look at what this looks like for a second, because it merits looking at for a moment. When you get a change event from a change notification from a change feed, you get two properties, new val and old val. This gives you everything you need to figure out what's going on in the system. If new val is null, it means the document was deleted. If old val is null, which is the case here, it means the document was created, and it gives you the properties. If old val and new val are not null, then it'll give you the preceding and after state, the preceding and post state of the change. So you can do a diff manually in the client if you like. You also get states about when the change feed is first starting up, so you can replay events from the table if you want to pick up after a disconnection. And so we can see some folks are starting to post some photos here. And so the nice thing is that these apps, they know nothing about each other. They're running as completely different servers. The only thing that's connecting them, and including this device as well, is just RethinkDB. So what's nice is that you get this sort of streaming updates. If we can take out, let's say, this photo, like, can't really see it very well. Sorry, whoever this is. But if I remove it, you can see that it instantly gets updated on the left, the right, and then in the change feed, you can see that new val is null. And so the fact that you get these sub-millisecond updates across clients means that you can just rely on RethinkDB to manage all these complex interactions. And so you can go on GitHub to check out the code yourself if you want to. Come find me later, and I'll give you a little URL to look it up. It's a good example of using RethinkDB in a more complex environment. And so this is what it looks like, our same diagram from before. We have 3 stateless services, the Raspberry Pi, our web service for the web front end, and then the Twitter service that tweets whenever new photos are available. And all these are just talking to the RethinkDB cluster. So this is important for a number of reasons. So if we want to move the web forward, right now we have React in the front end, which has unidirectional data flow, lots of parallelized actions, very asynchronous. Node is amazing. JavaScript is everywhere. And the reason why isn't, I don't think, just because it's JavaScript but at the back end, but because it's massively parallelized, massively asynchronous. Really designed for these kinds of rich applications that people want to design and build, which is why we find things like Electron or React Native, different environments where these tools are starting to show up. And so RethinkDB brings that knowledge to the database level. And so you have full stack reactivity, full stack stateless unidirectional data flow, parallelized operations. And as I said, polling is cumbersome. It's hard to maintain. The push access model simplifies real-time architectures. One source of truth means that it's easy to manage state. And RethinkDB is the first database for the real-time web. So you guys can join us on Slack. We have a very active, very positive community, like 2,000-something plus people there right now, and they're all very happy to help newcomers get situated. I'm going to be over there talking with folks if you guys want to come and say hello. I'm here for an hour or two before I got to fly back to SF. But I want to talk just briefly about a new project we have at RethinkDB as well. This is the shirt that I'm wearing is Horizon. So a lot of the stuff that I needed to do to build this app was things like work with Node, work with Socket.io, figure out how to do access control, figure out how to do security permissions. So we had a long time people were trying to take the work we did with RethinkDB, like the change feeds, and just use them in the browser. And they were like, I want to build my real-time app, and there's a lot of work to get started. And we looked at it, and we're like, well, you shouldn't access your database directly from the browser, but there is an awful lot of work to get done. A lot of the sort of common boilerplate patterns of building modern apps. Things like access control permissions, session management, all this sort of stuff that's really frustrating and is intimidating if you want to get started with JavaScript. And so over the past few months, we were building this project in quiet, and we just released it about a month ago, and it's called Horizon. So Horizon builds on all of the technology we built with RethinkDB, and it brings it to the browser. So it's a real-time open source backend for building JavaScript apps. It comes with a convenient set of APIs and tools. You start building your app using just a JavaScript API from the browser. Under the hood is communicating with Rethink and using the backend. You can think of it like Firebase, but on your laptop and open source. And once you've moved past what's available in the browser, you want to extend it with custom backend functionality, you can then take the entire stack and hook it into something like Koa or Express or Hoppy and continue to extend your app on the backend. So our vision with Horizon, and we see it as an easier way to organize JavaScript and to get started with JavaScript. But fundamentally, it makes it easy to quickly prototype your web and mobile app and scale it to millions of users. So there's already a pretty big community around Horizon building for things like React and Angular and Ember. If that sounds interesting to you, come chat with me. I have a bunch of really nice t-shirts that you guys are welcome to grab. And if you want to get started with Horizon, you can find it at horizon.io. So RethinkDB and Horizon are really what we see as like the next generation for building real-time apps, the architecture necessary. And we're an open source organization. We do all our work on the open. We have an open development model. I would urge you to come find me, come talk to me, or come join us on Twitter or Slack and GitHub, and you can get started with some things here. So if you have any more questions, I'll be around, but thanks a lot for your time. I appreciate it. That's good.